Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching the latest question paper from your yesterday's physics pre-board exam. So we are going to discuss all the questions that came in your exam and how you could have benefited if you have watched the Brahmastra series, and also if you are from Bangalore South, we are going to discuss Bangalore South question paper because today is 17th of January. In 16th of January in Bangalore South pre-board of physics is already over, so we will discuss that question paper. And those who are not from Bangalore South and your physics exam is still pending, you can obviously check this video for all the guides, all the reference that you want, right? So this will going to help you even if you have completed the exam or if you have even you are going to give the exam, right? So we are definitely going to discuss all the solution for all the MCQs and all the numerical questions, and other questions I will briefly discuss about the answers, and if you have seen my Brahmastra series, how it could have helped you to answer those questions, right? So let's start with the question paper. So the paper code is AS, that is Bangalore South question paper, and it is second PU preparatory board exam. The question paper looks like this. So just a screenshot of the question paper. Now how was the question paper? Question paper difficulty level according to me is medium. It is not super hard, not super easy. Okay, the level was medium. Now what blueprint they have followed? They have not strictly followed any of the given blueprint. There are certain deviations from the blueprint, but overall it's okay. It's a mixture of all the blueprints, not a single blueprint was followed, right? Now some uncommon questions were asked. That's why I gave it a medium rating, not easy rating or not hard rating. Some questions were uncommon, we will see that as well. So first we will start with the MCQ and fill in the blank section. So let's see the MCQ questions first. Easy question. Coulomb's law of electrostatics agree with the number 1, Ampere's law. Ampere's law deals with current, Coulomb's law deals with static charges, so there is no relationship between Ampere's law and Coulomb's law. Newton's third law of motion. So in this case we know that if we have two charges Q1 and Q2, okay, the force on this is basically given by F12 and force on this is given by F21. Now we know that these two forces are equal and opposite, so F in vector form, F12 is basically nothing but minus F21, which is nothing but Newton's third law of motion. So forces are equal and opposite, and every action has equal and opposite reaction. So this is, if you consider this action, the opposite other one is reaction. Definitely there is no differentiation between action and reaction, but obviously you can say if there is an action there will be a reaction. So this, according to Newton's third law of motion, Coulomb's law definitely agrees with Newton's third law of motion. Other motion, again, Ohm's law is based on current, so evidently current is moving charges, no relation with static charges. Faraday's law, again, it is about induction, electromagnetic induction, no relationship between Coulomb's law and Faraday's law. Now let's move on to the next question. There are two statements given. First statement, the magnitude of electric field is given by the change in the magnitude of the potential per unit displacement. So magnitude of electric field is given by magnitude of change in potential per unit displacement, so dV by dx. Okay, so this is the statement. So definitely this is a correct statement because electric field is basically dV by dx or delta V by delta L that you have done in your textbook. Statement 2, electric field is in the direction in which the potential decreases the steepest. So obviously this is also correct. That's why when we write, we generally write Ex equals to minus dV by dx when we include the direction, right? So basically this negative sign represents that when potential decreases in that direction, electric field increases, right? So electric field represents the direction in which potential decreases the steepest. That is also a correct statement. Both statements are correct, so option A is the correct answer for this question. Now let's move on to the next question. Current through unit area normal to the current in a conductor. So current through unit area per unit area. Current through unit area means current divided by area, and normal to the area through which current is flowing is basically the current density J. This is nothing but current density J. Right, so this is the definition of current density. So current density J, direct question. Now let's move on to the next question. The substances which have tendency to move from stronger to weaker part of the external magnetic field. So basically stronger part, suppose we have a magnetic field. So magnetic field obviously represents in the direction of increasing magnetic. Suppose there is a this region is stronger magnetic field. How to represent stronger magnetic field? By increasing more number of lines. So a substance which is moving from stronger magnetic field to weaker magnetic field. So basically it's a diamagnetic substance. So correct answer is option D. And also you can say that ferromagnetic substance, paramagnetic substance both moves from weaker magnetic field to the stronger magnetic field, right? But in this case it is moving from stronger to weaker. Definitely it is repelled by the magnetic field, so it is a diamagnetic substance. Now next question. Lenz's law is analogous to the law of conservation of energy. We have discussed this multiple times. Lenz's law is analogous to conservation of energy, so this is also a common easy question. Now SI unit of self inductance is SI unit of self inductance, SI unit of mutual inductance, SI unit of any inductance is always Henry. Okay, you have to remember that. We have solved similar problems in different chapters, so this is also a easy question. Next question, the electrical resonance phenomena is exhibited by, so we have done decode NCERT chapter, also we have discussed this during our AC chapter, that when L and C both are present, only then resonance is possible. So only L and C in the circuit. R and C, R and L does not produce resonance. C and L both has to be there. Okay, R is not compulsory. If R is present, it will be RLC circuit, but definitely L and C will definitely be there, then only you can see resonance, right? So L and C in a circuit. Now next, electromagnetic waves with highest frequency are. So frequency highest means lowest wavelength. Okay, highest frequency means lowest wavelength. Now you have to see here what are the options given. Microwaves and radio waves are in the lower frequency region, right? They have very big wavelength. In fact, radio waves are the highest wavelength. So radio waves, and after that microwaves in the next category. So microwaves are the second highest wavelength. So they are also highest wavelength means lower frequency. So highest frequency means UV rays. Sorry, pardon me. V was there, I didn't see it. Actually the space is instead of having space between V and R, their space is between U and V, unfortunately. Anyway, UV rays is okay, but gamma rays are the highest frequency. Okay, gamma rays have the highest frequency, so that's why the answer will be gamma rays. Now let's move on to the next question. Expression for magnification of simple microscope. Simple question, m is equal to 1 plus d by f. So this is a question that you have to remember. You have to answer this question. So expression for magnification of simple microscope is 1 plus d by f. Now which of the following is not use of a Polaroid? So Polaroid, so out of the 4 options there must be 3 uses of Polaroids and 1 is not, which have to identify that. So we will discuss all the options. To control the intensity of light, yes, intensity of light can be controlled by using Polaroids. That's why in sunglasses Polaroids are used, so that you don't get the direct sunlight into your eyes. So that is a controlling of the intensity. To produce maximum intensity of light, actually it is not correct. Polaroids can always decrease the intensity, it cannot increase the intensity. So maximum intensity is not possible using Polaroid. So to me this is a possible answer, but if you are not sure, let's check the other options. In photographic cameras, obviously in photographic cameras we use Polaroids to picture, right? The sensor of photographic camera uses Polaroids to filter out different wavelengths. So photographic cameras do we use Polaroids? In 3D movie cameras, are obviously collect two different Polaroids are used. Okay, I briefly explained how 3D movies are captured. Maybe I will make a video later on in future once you are done from this exam stress, that how 3D cameras work. Okay. Now, so basically these all A, C, D are the uses of Polaroids. It is given in your textbook. Even if you don't know the exact principle, it is given in your textbook, but this is not given in your textbook. So definitely this is the answer. To produce maximum intensity, either diffraction or interference are used, not a Polaroid. Okay, so that is the answer that you should know. Now, next question: light of filament bulb is viewed through by holding two blades from a single narrow slit. Shows. So this is an interesting question, uncommon question. Never seen this kind of interesting question in the PU board previously, but this is an interesting question. So filament, first of all, bulb filament generally is not a first of all, it is not a monochromatic source. Okay, so bulb filament, this bulb filament means incandescent bulb. So you may have seen this kind of bulb in your home previously, right? So first of all, it is not a monochromatic light. To observe diffraction or interference, the first condition is the light should be monochromatic in nature. Okay, this is not a monochromatic light. It is kind of yellowish white light. So even yellow, presence of yellow is more, but it is not. If you consider an ideal incandescent lamp, that means it is a white light only. So it contains all the colors. So it is not a monochromatic source. Secondly, you cannot also consider it to be a point source. Why? Here you have a lot of different points. So it is also not a point source. It is a multiple source, and all these sources are not coherent. If they are coherent, then still you could have considered it. Okay, it can show some kind of diffraction, but this is not a coherent source. This is not a monochromatic source. So if you see a light, normal light through a small hole, you will see a bright spot. So what you will see, a single bright band. You will not see anything else. So basically what they are saying, you have two blades, you put it towards the light and you observe it. You will see a bright band, right? You will not see anything else. So only bright bands will be visible. Nothing else you can see through this. Next question: the minimum energy required to free the electrons from the ground state of hydrogen atom. This question was also discussed in my Brahmastra series, in my cassette series, that is 13.6 eV. The value is very common. So the minimum energy required for an electron to ground state is 13.6. Any other state is 13.6 divided by n square. Okay, you have to remember that 13.6 divided by n square is the for any other state. Okay, that is the energy of that state, negative energy of that state. So you have to provide that positive energy to make it free. Now from the ground state, this is 13.6 eV. Easy question. If it was a cassette question, they might have asked you what is the energy required to free it from second state, second excited state, okay, or third excited state, like that. N is equal to 3. Now 13. Nucleides with same atomic number and different mass number are called. So this question was also discussed. Same mass number, same atomic number means it's the same atom. Okay, number of protons are same, so basically it's the same atom. Only thing is mass number is different, so that means they are isotopes. They are isotopes. Okay, same atomic number but different mass number. So chlorine 35, chlorine 37, common example, uranium 98, uranium 238, uranium 232, they are also isotopes. Okay, they both have 92 as the atomic number, right? So atomic number same but mass number different, they are called isotopes. Now the term hole in a semiconductor is used for, this is also very common question, a vacancy created when an electron leaves the covalent bond. It is easy question, so I am not putting focus on the other options and wasting your time. So we want to finish this paper discussion as quickly as possible. So the term hole is basically a vacancy created due to when an electron leaves the valence bond. That's how a hole is. It is not an antiparticle, it is not a absence of free electrons, it is not the artificially created particle. This question is also discussed in my Brahmastra series, right? Now question number 15. Another new kind of table question. Okay, table question we have discussed, but not particularly this one. Identify the correct match in the following. So an n-type semiconductor, a p-type semiconductor, a pure semiconductor. These are the three options on column 1. In column 2, tetravalent, has donor impurity, has acceptor impurity. Now we know that a pure semiconductor does not have any impurities. So basically it is saying that pure semiconductor obviously will match with option A. Okay, now if you see the answer itself, you can answer the question itself without even looking for any other correct thing, because in the given option 1 is matching with A in only one case. Okay, so this is an easy, even though the question is little tricky in case of N and P type, but based on the option this is super easy, because obviously a pure semiconductor does not have any impurity. That means it cannot have any kind of impurity, so it is a tetravalent. This is also correct. We know that any pure semiconductor like silicon or germanium, they are tetravalent, they are valency 4, so they are tetravalent, right? Now an N-type semiconductor, what is an N-type semiconductor? N-type semiconductor is when you dope a pure semiconductor with a pentavalent material so that it gives you an extra electron. So that extra electron is called donor. So the impurity that is coming in, they are donating one extra electron. So basically it is saying that if you want to join our institution, you have to donate some electron to us. That is how this semiconductor functions. So N-type is a donor impurity and P-type has a acceptor impurity. Okay, basically P-type is saying if you are coming to our institution, you have to accept one electron from us. So that is what P-type semiconductor are saying. So you can see that option A, 1A, oh sorry, my mistake, 2A is this, 3A. My mistake, 3A has two options, sorry. Extremely sorry that I guessed the answer incorrectly. So 3A has two options, so out of these two options you have to check the other options as well. Anyway, so 3 is A, 1 is B, and 2 is C. Okay, so one more way you should remember that they generally do not give direct match. Okay, that is also one other trick that you might answer. So pure semiconductor do not have any impurity, so they are tetravalent. Correctly you have guessed. And N-type semiconductor, this is a little bit tricky to identify donor. Maybe you are thinking that P-type has a donor impurity or N-type has an acceptor impurity. Generally they don't give direct matches. So 1 should match with B and 2 should match with C. Right, this is another way to guess the answer in case you don't know the answer correctly. Okay, now this is not always true, but in this case this is correct. Now let's see the fill in the blanks question. First question, a galvanometer is converted into an ammeter by connecting dash in parallel. Now if you see the options, transformer, low resistance, magnetic field lines, rectifier, relative refractive index, high resistance. So either low resistance or high resistance. Now high resistance is connected in series to convert a galvanometer into a voltmeter. So here the answer will be low resistance. You can remember it, or you can analyze it and answer it. Okay, dash do not intersect each other. So we know that magnetic field lines, they do not intersect each other. So answer will be magnetic field lines, right? Now what? Hysteresis loss is a loss of energy in a transformer. Hysteresis loss is a loss in a transformer. Nothing else is there for your hysteresis loss. So you should, I told you in my electromagnetic induction chapter that it might come. So this is one of the type of losses in a transformer. Refractive index of glass with respect to water is called, this is a direct answer, relative refractive index. So relative refractive index. I am writing in short. This is too long to answer. We have entire question paper to answer, right? So relative refractive index is the answer for this question. Easy question. Now semiconductor PN junction diodes. In semiconductor PN junction diodes used in dash circuit, again rectified circuit, only one possible option, rectifier circuit, right? Only doubt was between low resistance and high resistance in the first option. Otherwise all other fill in the blanks are quite easy. If you just read it, try to understand, try to analyze using your head, you can answer them easily. Now let's move on to the section B, 2 marker questions. The first question is, what is the direction of net electrostatic force on an electric dipole when number 1 it is P, that is dipole moment, is parallel to electric field and P is anti-parallel to electric field in a non-uniform electric field E. So this is very interesting question. So suppose this is the electric field, this is a dipole. Okay, dipole moment is parallel to the same direction as electric field. So electric field is generally in the direction of increasing electric field, right? So electric field is small here, electric field is higher here, so that's why it is moving in this direction. So this represents the direction which is the electric field is increasing. Okay, now if this arrow represents the direction of increasing electric field, now what is the direction of P? P points from negative charge to positive charge. That is a very important point to remember, that in case of dipole moment always points from negative to positive charge, right? So now what is the force on this? So force on this is, say, E plus, right? Positive charge will definitely experience a force in the direction of electric field, right? And the negative charge will experience a force in the opposite direction of electric field, E minus. Now because the electric field is increasing in this direction, E plus will definitely be greater than that of E minus. Now if it is an uniform electric field, E plus and E minus would have been equal, but they have said a non-uniform electric field, so whoever has the direction in their favor, that is the direction increasing electric field, he will be more. So in this case the resultant force will be in this direction. So resultant force will be in the direction of electric field. So first case, number 1, in the direction of E. Similarly, second case, it will be in the opposite direction of E external, right? One mistake that I made in this case was, this is not electric field. Electric field is already present, right? So it will be not electric field, but it will be force, right? It will be just a simple force. It will be F plus, it will be F minus, and F plus is more than F minus. Okay, so F plus is more than F minus, so force in the direction of positive will be more. In the opposite case where electric field is in this direction and negative, as you can see, negative charge is in this direction, positive is here, the dipole moment is in this direction, electric field and dipole moment are opposite direction. So in this case, force on the negative charge will be in this direction and it will be more because it is experiencing more electric field, whereas the positive electric field will experience a less force in the direction of electric field. So in this case, F minus is greater than F plus, so the resultant force will be in the direction opposite to that of the electric field. The exact explanation, exact answer is given in your textbook, in your NCERT textbook. The question is not out of syllabus, so this is exactly given in your textbook. You can read it once to answer this, right? Now next question, mention factors, but that question was not common. Okay, that question was never asked from this electric field chapter. Mention factors on which the capacitance of a parallel plate capacitor depends. Now my friend, that is myself from another dimension, another universe, in Few to Brahmastra series, I have discussed the exact question. The important thing is that my question from this chapter number was 22, and if you see the question paper number is for this question is also 22. It is completely coincidence though, no relationship. I have not set the question paper, but there is a good coincidence that both question paper numbers are also matched. You can see the timing for the chapter also, electrostatic potential and capacitance, in Pre to Brahmastra series. I have discussed this at 24.37 minutes. If you have watched this video, definitely would have answered this question. Now what is the answer for this question? Answer to this question is easy, so that's why I am giving it. Otherwise, maybe if the question is common and I have already discussed it, I will not give it. So first of all, capacitance is K A epsilon naught by D. Right, this is the general formula. So you have to mention any two they have mentioned. So capacitance is directly proportional to the area, capacitance is inversely proportional to the distance between the plates. So this is the two condition. There are other conditions. That another condition is that it is directly proportional to the dielectric constant of the medium between the plates. So these are the three conditions. These are the only three conditions that you need to know, and any two if you write, you will get full marks. Right, now next question. Define number 1 electric polarization of dielectric and dielectric strength. Now this is also not super common question. I discussed this in my K-set lecture briefly and in Decode NCERT as well. So let's see what is the answer to this question. The dipole moment per unit volume is called polarization and is denoted by P. For linear isotropic dielectric, P is given by epsilon naught chi E E vector, where chi E actually it is spelled by like this chi, but while spelling we say ch is k, so it's chi. Okay, ch is spelled as ka, so this is chi. Okay, so chi E is a constant characteristic of the dielectric and is known as the electric susceptibility of the dielectric medium. So this is the definition of electric susceptibility of the medium. This is the electric polarization. Okay, and then dielectric strength, the maximum electric field that a dielectric medium can withstand without breakdown of its insulating property is called its dielectric strength, and it's about, for air it is about 3.6 into 10 to the power minus 10 to the power of 6 volt per meter. So this is a value given. So if you write this this answer, you definitely get the full marks, but for polarization up to this much is okay. For dielectric strength you have to write the entire thing with the example, okay, for air. Okay, it is not super difficult. Now next question, draw a graph of resistivity versus temperature of metallic conductor and semiconductor. I discussed this in my K-set lecture, unfortunately not so much in Brahmastra series, but the graphs are easy to remember. So for a conductor, this is for a conductor, graph for conductor. So as you can see, that for conductor it increases like this, and for semiconductor it decreases with increase in temperature, and for conductor it increases with increase in temperature. So for a normal conductor, as you increase the temperature, it becomes less and less good conductor, whereas for a semiconductor, as the temperature increases, it becomes a good conductor. So that is the difference between semiconductor and conductor. Graphs are exactly opposite, so you can remember it is easy to draw, not super difficult. The values are not important, but you have to be careful that you are plotting rho across this and temperature T across this. That is very, very important. Now next question, write the expression for Lorentz force acting on a charged particle moving in uniform magnetic field and electric field, and explain the terms. So this again I will take my help from myself from another dimension. So I am Dr. Strange, so my friend another Dr. Strange from multiverse of madness is here. So he already explained what is Lorentz force, how to write it, what are the meaning of the terms, and it is explained in the Preview to Brahmastra series, physics, moving charges and magnetism, most expected question, and the time duration was 48 minutes 15 seconds. If you have watched it, you could have answered this question. If you have studied the topic, definitely you can answer, but even if you have not studied, if you have seen my video, you could have answered this question. So this is directly from another Brahmastra series question. Now let's move on to the next question. Mention principle of AC generator. Write an expression for instantaneous EMF of an AC generator. Now principle I have discussed, the formula I have not discussed in my Brahmastra series, so I am not giving you the time stamp from my video, but here it is. The formula is epsilon is equal to NBA omega sine omega t. Right, so principle is an AC generator converts mechanical energy into electrical energy by charging the by changing the flux linked with the rotating coil. So this is the principle, and this is the formula, NBA omega sine omega t. Don't get confused, it is talking about AC generator, okay, not about anything else, right? Not about a galvanometer. It is only AC generator. It is from the chapter electromagnetic induction. Okay, now next, what is meant by displacement current? Write his expression. Again, I am not going to answer it because he is here to answer this question. So displacement current, the current due to changing electric field, is called displacement current, and it is given by ID is equal to epsilon naught d phi E by dt. Right, and it is again done in my electromagnetic waves chapter in the timestamps 20 minutes. Okay, so this is a very small chapter, very small duration. You should have definitely watched it and you could have answered it. Right, now let's move on to the next question. The threshold frequency of a photosensitive material is 5 into 10 to the power of 14 Hz. Find its work function. H is equal to 6.625 into 10 to the power of minus 34 joule second. Okay, now so frequency is given, this is numerical, so definitely we have to solve it. Right, so nu is given as 5 times 10 to the power of 14 Hz. Okay, and H is given as right. So what is the definition of work function? Work function is basically given by H nu. Simple as that. Now first, this is joule second, so the unit will be in joules first, then we will convert it into electron volt. Okay, so first is obviously H is 6.625 into 10 to the power of minus 34 into 2 marks question, so it will be definitely an easy question, right, without much difficulty. So it will be 5 3s, it will be 9.125 approximately. This will be the answer. Okay, you can check it, into 10 to the power of minus 20. Okay, obviously 5 3 33, sorry 33, my mistake. 5 6 are 30 and 5 6 are another 30, so that 30 will come inside, so that will become 33. Okay, 33.125, that is the answer. Use your calculator and calculate the exact value. This is in joules. Okay, now to convert it into electron volt, phi will be in electron volt will be 33. This is a very small value, right? So for an electron this does not make any sense. For electrons we generally convert it into electron volt because that is more convenient for an electron. So it will be 1.6 into 10 to the power of minus 19. Okay, so it will be approximately 2 electron, approximately 2 electron volt. You can check the answer, calculate it using your calculator and tell me the exact value. I don't use calculator in my so long, I don't remember when I last used calculator, so I try to do whatever exact value is not required for me. Even an approximate value is okay, because I am want to train my mind, and in case I need, I can any day use the calculator to find the exact value, right? So anyway, so this is the answer for this question. Easy question, not super difficult. So 2 marks is scoreable if you know that work function is nothing but h nu, right? Now section 3, 3 marker question. Mention basic properties of electric charge. Again another question from another universe, another dimension of Brahmastra series. Here I have discussed the exact question, additivity of charges, quantization of charges. So everything is explained by me in another dimension if you have watched that video, right? So let's move on to the next question, which is derive an expression for magnetic field due to a long straight conductor carrying current using Ampere's circuital law. Now let's see, that part is also done, and I will not going to discuss it here. The entire derivation was done in my lecture. If you have not seen any of my lecture, at least try to download the class notes. The class notes are available in our WhatsApp channel. For that you have to first subscribe to our channel, like this video, and then you can go to join our WhatsApp channel. It is a completely safe and secure channel. No identity theft will happen from there, so you can securely join that channel and download the link. It is already published yesterday, I think, so you can download the class notes, where these things you will get in a written format, obviously handwritten format. Whatever class notes we are doing, the exact notes are given to you, so you can download it from there. So again, or else you can check this particular link at this time. This is a done very easy question, not super difficult, and exactly the same question is there. Now the number difference is there. Obviously there is that coincidence happened only once. So let's see the next question. Define magnetic susceptibility and then magnetic relative permeability, and write the relationship between them. This is not a super common question from this chapter, but we will see. Magnetic susceptibility chi, it is dimensionless quantity that measures how a magnetic material responds to an external field. So whether it will attract, whether it will repel, whether it will weakly repel, so that is determined by the quantity called magnetic susceptibility. And relative magnetic permeability, mu r, it is a dimensionless quantity that measures the ability of material to support the formation of magnetic field within it. So basically, if you apply magnetic field into a material, whether the magnetic field lines are getting concentrated or getting repelled, so that is determined by mu r. So basically they are like cousin brothers, and or not even cousin brothers, they are brothers differentiated by only mu r is equal to 1 plus chi. Okay, so they are like Markova and Stevova. They are twin brothers, even though they don't look like twins, but one was born a few minutes later the other, right? So that's why Stevova was elder brother, Markova was a younger brother. But when I was a cricket fan, when I was watching cricket, so always I thought that Stevova is much older than Markova, but actually in truth they are only few minutes apart. Okay, that point of time it was very difficult to guess, because Stevova always looks like a little older, Markova was always looks like flamboyant, flashy, and there was a time when Markova and Sachin Tendulkar was compared easily, right? So they are like those Markova and Stevova in the chapter Magnetism and Matter. They are related by only differentiated by 1. This formula is important, by the way, if you are preparing for KSET, or in some cases they ask the same question in numerical, in MCQ also. So mu r is given, what is chi? So they are just, you have to add 1 and to calculate it, right? And in KSET they will give you one value, and you have to calculate the other value using this, and then you have to apply it to calculate some other value. You have solved some problems, so this is a very important equation for KSET. Now next question, explain magnet and coil experiment to demonstrate the electromagnetic induction. I have discussed this question. Language was slightly different, but question easily understandable. The same question was discussed, and it is discussed in the electromagnetic induction chapter, so you can go and check this, or you can read it from here as well. So this is also discussed in my Brahmastra series. What else? Define critical angle and mention the condition for total internal reflection of light. Now when a ray of light enters from a denser medium to a rarer medium, it bends away from the normal. The angle of incidence corresponding to the angle of refraction is 90 degrees, is called the critical angle IC for the given pair of medium. Now these two I have discussed in my Brahmastra series. This question I have not discussed. I have discussed this for a 2-marker question, but here they have asked you a 3-marker question along with this. So that's why I thought, okay, let me give the answer incomplete. So this is the answer for this question. This is already discussed in my ray optics chapter. If you have doubt, you can go and check it any time if you want. Now write any 3 Hallward and Leonard's observation of photoelectric effect. Now this question is also discussed in a separate way. I asked my question was discuss 3 experimental observation of photoelectric effect, but they have changed the language. They have said Hallward's and Leonard's observation, which is nothing but observations from photoelectric effect experiment. So I decided to give the same answer here as well that I gave in my Brahmastra series. What is the answer? For a given metal, no electrons are emitted if the frequency of the incident light is below a certain minimum value. It is called the threshold frequency, nu naught. Okay, not nu DOS, this is wrong. Regardless of the intensity of the light, photoelectric emission occurs without any noticeable delay after the light strikes the surface, even for a very low intensities. What is the third point? The maximum kinetic energy emitted electrons increases linearly with the frequency of the incident light above the threshold frequency. These are the 3 points. This question is same as the question that I discussed in the Brahmastra series, that is 3 observations from photoelectric experiment, photoelectric effect experiment. Okay, so the same question, because Hallward and Leonard, they did the experiment, so they primarily was responsible for discovering photoelectric effect, where later on Einstein explained it using his theory. So that is also important, 3 explanations of Einstein's photoelectric effect, but this is also an important question. Now draw schematic arrangement of the Geiger-Marsden alpha scattering experiment. What is mean by impact parameter? So you have to draw the schematic arrangement, which is very tedious. I don't think anyone would try to answer this question, because any small mistakes might cost you marks. So you should not answer this question, because this drawing is not super easy. So you have to show something like this. There is a alpha particle scattering here, alpha particle is going here. Okay, then there is an entire thing, and you have a detector here. So that diagram is not easy to draw. Okay, and some parameters has to be there, but the impact parameter is important. Impact parameter is the smallest distance between the nucleus and the alpha particle. Impact parameter is the smallest distance between the an alpha particle and the smallest distance of approach, smallest possible distance between one alpha particle and the nucleus. Right now for the alpha particle which is moving directly towards the nucleus, it will just rebound. So impact parameter is exactly smallest for scattering angle of 180 degrees, and impact parameter is largest when it is passing directly without any contact. That is for impact parameter is largest for scattering angle of 0 degree. So that is one objective question that came in PU board or also in KSET. So that is why I think, okay, impact parameter you need to know, but draw a schematic, you can skip that part. Now again, this question was discussed in my chapter, nuclei chapter. The question was, find the energy equivalent of one atomic mass unit in joules and in MeV given the speed of not light, sorry, it is light in vacuum is 3 into 10 to the power of 8 meter per second. One atomic mass unit is 1.66 into 10 to the minus 27 kg. Magnitude of charge of electron is 1.6 into 10 to minus 19 coulomb. Now exact Answer for this was 99979 into 10 to the power 8 meter per second. If you use this value for 3, you will get slightly bigger value than this, but that is fine. You just need to apply Einstein's law, E is equal to mc square, put the value of m, put the value of c, square it, you will get it in joules, and then divide it with electron volt, you will get in electron volt, and then finally in mega electron volt it will be around 940 electron volt if you are using 3, and it will be around 15 into 10 to the power of minus 11 joules. Okay, this is a problem, easy problem, solved during my class if you have seen it, right? Now let's move on to the 5 marker, that is derivation section. Now let's see. Derive an expression for electric field at a point outside a charged spherical shell using Gauss's law. Have I done it? Let's see. Yes, I have done it. I have done it in my electric field chapter exactly, and here there was a bonus question. That's Gauss's law of state Gauss's law of electrostatics. That question is taken from your previous year question, where they have asked, given this question as 1 plus 4. Here in this pre-board exam they have given it as a 5-mark question, so you can score easy 5 marks if you know how to answer this question, right? Now next question, obtain an expression for conductivity of free electrons in a conductor where an electric field established across it. Now I have not done this derivation. This derivation is slightly tricky derivation, but if you have seen my video on decode NCERT from the chapter current electricity, there I have discussed it. Okay, there I have discussed is what is the value of sigma n is square by something, I don't exactly remember the value, but this is the starting point. So this is the derivation I have done in my n square by m, I think, into tau. Yes, so this derivation I have discussed in my decode NCERT chapter. The derivation is slightly rigorous. Some things you have to remember, not super recommended for you if you want to get this question, but if this question comes in your final board exam, then maybe you are unfortunate, because this question never came in the past, so maybe in very old times, not in recent times. So in my opinion, this is not super common question, so you can skip it. Now next question, again I have discussed this question. Deduce an expression for force between two parallel current carrying conductors and hence define ampere. Exact the same question came, and if you see, I have put 3 stars in this question. So this is a 3-star question. This is a super important question, right? So definitely this question might come, and I have already discussed in my Brahmastra series. So you see, if you have seen my Brahmastra series completely, you could have answered 2 of the derivations. Now let's see. Last, prove law of refraction of light when a plane wave front passes from rarer medium to denser medium. Give any 2 differences between constructive and destructive interference of light. Now if this question is from my Brahmastra series, then you could have answered 3 out of 3 if you have watched all my Brahmastra series videos. So now let's see. Yes, I have discussed it in my lecture. You can check it out in wave optics chapter, but the second part of the question is not discussed in the same question, but yes, it is also discussed in another question. So both questions are discussed. Okay, the difference between constructive and destructive interference. So that's how I have written it. So intensity increases, intensity decreases, condition for constructive interference, condition of destructive interference, everything is written here. So you could check that video as well, right? Now let's move on. We have one more derivation, long answer type question, not derivation. Define valence band and conduction band. Explain classification of solids using band theory. This is a very uncommon question from this chapter, and that is why I say do not do any kind of suggestion from the derivation part. Derivations, any type of derivation might come from your board exam, right? So this is a question which is not common, and I expect this question will not be coming in your final exam. Full wave rectifier or half wave rectifier will come, right? But maybe this question might come, but I am not going to discuss it. This is never asked in your previous year exams, not in the main exam. In the side exam 2, exam 3 might be asked, but not in the main exam, so I am not going to discuss it. Now let's see. This is not 4 marker, this is 5 marker numerical questions, right? So let's see the questions. 3 capacitors, 3 microfarad, 4 microfarad and 6 microfarad are connected in series. Determine the effective capacitance of the combination. So we will quickly solve it. 3 capacitors connected in series. So series combination means the equivalent capacitance is basically like a parallel resistance combination, right? 3 are there, so you cannot use any shortcuts. You have to use the long cut, right? 3 plus 4 plus 1 by 6. So what is the LCM of all of this? LCM is 12, definitely, right? 3 4s are 12, 6 is common between them. So 3 4s are 12 plus 3 4s are 12. So 3 into 4s are 12, 4 into 3s are 12, 6 into 2s are 12. So this is the value. So 7 plus 9, so 9 by 12. So now you have to take the reciprocal. Be careful, as I said, many students leave the answer here and get 0 marks because they have not reversed it, right? So now reduce it, 3 4. So 4 by 3 microfarad. So equivalent capacitance is 4/3 microfarad. Okay, this is the first answer, 4/3 microfarad. Now what is else? Find the potential across 4 microfarad capacitor if the combination is connected to a 100 volt battery. Okay, so first of all, C equivalent is calculated. So now entire thing can be considered to be a battery and this C equivalent, right? So first let me draw a simple circuit diagram to explain that part, what I am saying. Initially there are 3 capacitors connected in series, right? Now in series combination, what is common? In series combination, common thing is, for capacitor, common thing is charge. Whatever charge is entering this, the same charge should enter this through this as well and through this as well. Okay, the charge is conserved, so charge cannot be created or destroyed, so charge should be conserved in series combination, right? Now if you replace it using a equivalent, the same charge should flow in the equivalent circuit as well, right? Right, now assume that the 100 volt that we are applying to this circuit, instead of applying to this circuit, if we apply to the equivalent circuit, then again the same charge will flow. Okay, so let's find that charge. Q equals to C equivalent into V, right? Q is equal to C equivalent into V, that is Q equals to, what is C equivalent? It is 4/3 and V is 100 volt. This is the charge. Okay, in microcoulomb, unit will be microcoulomb. Why microcoulomb? Because here it is a microfarad, right? So that's why it will be microcoulomb unit. Now same charge is flowing through that 4 microfarad capacitor as well. Same charge is flowing through the 4 microfarad capacitor as well. So if the voltage across 4 microfarad capacitor is represented by, say, V4, then again we can write Q is equal to 4 microfarad into V4, right? Because 4 is the microfarad, V4 is the potential across the of the capacitors, right? So we are trying to find that V4, right? Easy. Any doubt, mention in the comment. Now we just need to compare these two Qs. So 4 V4 equals to 4/3 into 100. Now this 4 cancel, so V4 is equal to 100 by 3, that is 33.33 volt. Okay, this is the voltage. Easy, not difficult, right? Now next question, let me know if you have solved this numerical or not and what was your answer. Now 2 cells, 2 volt 1 ohm, 4 volt 2 ohm are connected across a 5 ohm external resistor. So quickly draw the diagram, even though in this case the diagram is not super important, but it will help you to understand. So 2 volt 1 ohm and 4 volt 2 ohm. Also one more thing is that connected to a 5 ohm sorry, not like this, not series, my mistake. That's why I said always draw the diagram. Two volt, 1 ohm and 4 volt, 2 ohm. Okay, and such that they send currents in the same direction. So this is important, they are sending the current in the same direction. Okay, find the current and potential difference across the external resistor. So 5 ohm. Okay, you have to find the current and resistance, current and potential difference across the 5 ohm resistor. For that, what we will do, we will apply the combination of cells formula, combination of cells in parallel formula to find the equivalent EMF. What will happen if we replace that? So we will get that only one battery and one resistance. This is the simplest circuit, right? So if you know the formula, we can find the R equivalent, epsilon equivalent, and we can calculate it using simple Ohm's law, right? So that's why we will try to find the epsilon equivalent. Epsilon equivalent for parallel combination is given by epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2, right? So this is the easier formula to remember this. So what is epsilon 1 by R1? Epsilon 1 is 2 volt, 2 by 1 plus what is this, 4 by 2 divided by 1 by 1 plus 1 by 2. Okay, so it will be 2 plus 2 divided by 1 plus 1 by 2, that is 4 divided by 3 by 2, or 8 by 3. So epsilon equivalent is 8 by 3 volt. Just simple mathematics, not super difficult to answer. So 8 by 3 volt. Now what is R equivalent? R equivalent again it is simple, R1 R2 divided by 2 resistances, right, in parallel. So 2 resistances in parallel, this is the formula to calculate 2 resistances parallel. So that is basically 1 into 2 divided by 1 plus 2, that is 2 by 3. This is the resistance. Now this is the circuit. So the voltage supplied is 8 by 3 volt and this resistance is 2/3 ohm, right? Now what is the total resistance then? Total resistance is basically external resistance plus this equivalent, right? These are the two resistors in series, so you can simply add them. So 5 plus 2/3, that is 3, 15 plus 2, that is 17 by 3. This is the total resistance. Now what is the current? Now V is equal to IR, so I is equal to V by R, but only thing is instead of V it will be 8 by 3 and RT is 17 by 3, it will be 8 by 17. You can calculate using the calculator the exact value, whatever point value it will come. Okay, 1 by 2 approximately 0.4 point something, 0.45 or like that. Okay, and the voltage will be voltage across this, right? Voltage across this. So voltage across this will be this current 8 by 17 into 5, that is 40 by 17. Okay, so it will be 2 point something. Okay, 2 point something will be the answer for this. So this is the volt. So this is the answer, this is the answer. Let me know if you found this answer, if you have attempted this question or not. Not super difficult question, step by step methodical process, you can answer this question. Now a resistor, this is the question I suggest from this chapter, that is AC current, I have solved a lot of numericals from this chapter. If you have seen those videos, you could have answered this question as well. A resistor 200, but I am going to solve it as well. A resistor of 200 ohm and a capacitor of 15 microfarad are connected in series across a 220 volt 50 hertz AC source. Find the impedance of the circuit, calculate the RMS current in the circuit. Easy question. So voltage is given by 220 volt. It is an RMS voltage. Remember that anything if not specified, that means it is an RMS voltage. Only thing is that if we can find the impedance, we can find the RMS current. This is a very easy question. To find impedance, first of all we have to find capacitive reactance, that is XC. XC is 1 by omega C, that is 1 by 2 pi FC. That's it. Values you have to use a calculator to solve this kind of questions. Okay, 2 pi, F is 50 hertz and C is 15 microfarad. 15 microfarad means 10 to the power of minus 6, which will eventually go up and will become plus 6. Okay, so it will become 100, so 100 into 15, so it will be 10 to the power of 6. I am not going to solve the entire problem, by the way. I am not using calculators. You can use the calculators to calculate the exact value of this. So definitely 10 to the power of 3 divided by 1.5 pi. How I have done that? 1, 2, 3. 3 decimals I have taken. 3 zeros I have taken from the up. So it will be 100 divided by 1.5 into pi. You can calculate the exact values of this XC, which will be approximately 200. Not exactly 200, but I am approximating. I like to approximate, so approximately 200 ohm will be XC. Now resistor is also 200 ohm. So what is the you can check. If it is 300 ohm, then it will be easier for us to solve. Anyway, Z is basically given by R square plus XC square. Okay, if only resistance and capacitance are there, if only resistance and inductance are there, so it will be R square will always be there, and either XC or XL based on whatever is there, right? So this is the impedance. So basically it will be 200 square plus another. I am not sure about this value. I am asking you, do not trust this answer exactly. You have to check it using your calculator. That is the task for you. Okay, I am giving you the method, I am giving you the process. This is the impedance. Okay, and unit is compulsory, so ohm is this is the impedance. Now find the RMS current. So to find the RMS current, I is equal to basically V by Z, nothing else. Okay, V is 220 volt divided by 200 root 2. Okay, as simple as that, right? So it will be 1.1 divided by root 2. Okay, 1.1 divided by root 2. This is the current, RMS current. Don't divide it again by root 2. Very careful, because this is itself is VRMS. This is itself is VRMS. Okay, so IRMS is VRMS by Z. Okay, IRMS is VRMS by Z. So do not again, because in this case I have received 1 root 2 by coincidence perhaps, or because of my reluctance to calculate using calculator. But do not again divide this value with another root 2 to calculate IRMS. This value itself is VRMS. In case they have given it as a peak value, 220 volt peak value, then you have to divide it with another root 2. Very careful. Okay, in that case you have to divide it with another root 2, otherwise not required. Now next question, a glass double convex lens of refractive index 1.5 have radii of curvature of faces are 10 centimeter and 15 centimeter. Find its focal length. What will be the new focal length if it is immersed into completely water of refractive index 4/3? I have solved not exact question but same question. Values might be different, I am not sure, I have not checked if the values are same or not, but this question I have solved. Okay, this refractive index 1.5, 4/3, these two values I am not sure of, but maybe you can check, that problem might have the same values. Okay, so this is a very common question I have solved. So we know that 1/f equals to n minus 1 1/r1 minus 1/r2. What is this formula is? This is Lensmaker's formula. So n is given 1.5 here. Normally first we have to calculate for air. R1 is plus 10, always remember. So this is the convex lens, right? So R1 is for this surface. This surface is lies here. So R1 is always positive. Okay, because this is positive x-axis, and R2 is for this surface. So this surface R2 is always negative. Okay, remember that for a convex lens. For a concave lens it is opposite to that, right? So minus 1/R2 is 15, so it will be negative, right? Now you might ask, sir, they have not mentioned which side is what. You can reverse it, you will get the same result. Okay, because this negative and negative will cancel. So even if you have taken 15 first, 10 next, you will get the same answer. It does not matter because it's a convex lens. So 0.5 into 150. Okay, 15. I am a little lazy, so I am doing it like this. So 1/f equals to 0.5. 0.5 is basically half. So let me write that. Into 25 divided by 150. Okay, so 5 5s are 25, 3 5s are 15, 30, 5 6 are 30. So it will be 1/12. So f equals to 12 centimeter. Right, now you remember this value 1/6. Okay, remember this value 1/6. It will be very handy, because in the next part of the problem, only thing that you have to change this n. This will remain same. So when you immerse the lens into water, what happens is that this n becomes refractive index of glass with respect to water. Refractive index of glass with respect to water, that is Ng/Nw. Right, refractive index of glass is 1.5, refractive index of water is 4/3, so that will be 4.5/4. Okay, so that value will only change. Okay, and only thing that you have to do, you have to change it here. So let me solve that as well. These values are easily solvable without calculator, so I am keen to solve it. Okay, so 1/f dash, say now it is f dash, equals to 4.5/4 minus 1. Only thing that will change is this, right? You understood that? In GW minus 1. Okay, and if we have already calculated this part coming out to be 1/6, so it will be 1/6. Okay, you have to write the steps again, you have to show them again, but since I am trying to solve it quickly for you, you may have another exam coming tomorrow, so that's why I am solving it quickly. So it will be now 0.5 divided by 4 into 1/6. So basically it is 4 to the 28, 28 by 2, which is 0.5 by 28, 24. So it will be 1/48. So f equals to 48 centimeter. right? So f dash is 48 centimeter. I hope you have solved this question and answered it correctly, because I have done this in my numerical series. You have watched it. So numerical series part 2 is very, very important, because from there you are expected to get 2 exact numericals, but part 1 is like a fail safe, and for higher students, those who want to score more, they can check the part 1 video. Part 2 is must for all the students, right? If you have not yet watched it, go and watch it, and if you have not yet subscribed to our channel, don't forget to subscribe to our channel. Share it with your friends who have not a member of our channel but appear from Bangalore South. So do share this question video with them. I'll be back with decode NCERT and more soon.